Hello, everyone. It's a pleasure to be with you. My name's Charles Sternbach, and I'm the recent past president for APG. I want to wish the conference organizers great success. When I first started at APG, it was 38 years ago. My professor told me, he said, you must join APG if you want to be successful and serious in your business. And so in 1980, I joined, and I've been a member for 38 years. And during those years, I have been a staff geologist with Shell, a major international oil company, an exploration manager for an independent oil and gas company, president of two separate companies, one international and one domestic U.S. And now I have worked with APG, leading volunteers, a global organization of 30,000 members. And I'm now working with the University of Houston as an energy fellow. So I'm seeing a lot of different aspects of the energy business. What I have come to realize over these years is the importance of analogs in everything that we do, in people, in fields, in discoveries, in plays, and in basins. And so for me, the topic of exploration creativity has been a passion for 38 years. And we have to learn from all of the people who come before us, and our duty is to leave things better for those who come after us. And I like to start with something that many of you have heard a different version of, or a similar version, but in the world of exploration and in the world of geoscience, it's an immersive subject where the more you see, the better you are, whether it's rocks, field trips, fields, basins, or success case studies. Now, in the topic of superbasins, this is a topic that has been a lot of effort and focus in APG recently when I became president last year. A superbasin is defined by Pete Stark and Bob Frickland at IHS and fellow APG members as a basin that has 5 billion barrels of oil produced, 5 billion barrels of oil and gas equivalent yet to produce, many pays, many plays, and a significant infrastructure with services and supply chain. And there are hundreds of basins around the world that fits this category. But for instructive purposes, we have focused in my efforts on some of the biggest in the world, because the lessons from the very biggest basins are valuable for other of the very big basins and also for all basins. In the old days, when APG started out about 100 years ago, we're now in 101st year, technology transfer happened by people who were talented oil and gas explorers traveling around the world. But these individuals brought their know-how. However, today, it still happens by people going around the world, but we have communications and web communications that makes multimedia learning on demand and the ability to study work that others have done that are accessible as resources to you through places like the APG website. And we have not only some of the great explorers and discoverers, but we have their presentations that are available as PowerPoints and also with them explaining how they did it on audio-visual presentations. And if you want to know a tremendous treasure trove, if you go to the APG websites and then go to the publications tabs, and if you want to follow these, please write these down because these will be helpful to you. APG website, publications, search and discovery, special collections. Those are the key. And when you get there, you'll see a lot of special collections. But the ones in particular that I'd like to focus on are the discovery thinking and the playmakers. And they're the case studies of success, where we made a goal 10 years ago to for the celebration of APG's 100th anniversary last year to feature at least 100 men and women who were outstanding explorers explain their insights and visions. And I'm happy to say that it was a promise made and a promise kept. Last year, we had, for the 100th anniversary of APG, we actually totaled up 115 outstanding men and women explorers who have been participated in the Discovery Thinking program. And their lessons are available on the website that I mentioned. And I just want to show you three brief examples. So here's John Laruso, one of our APG Outstanding Explorers, recently passed away, but he was exploring in East Texas of the United States, and he noticed that along a Cotton Valley carbonate shelf margin, that there was a rather linear margin, but that in a particular spot there was an incisement, and so the margin had a real sharp notch taken out of it, and that there was a well log in there that had an extra thick sand up on the shelf. And so John, being a good geologist, intuited that down dip, that the sand had the potential to come down dip as in a possible turbidite situation, and he and his partners leased up a large acreage position and subsequently found a multi-TCF field called John Laruso Field. And so the lesson is, it's important to look for notches in shelves that may lead to down dip slope deposits or turbidites. Exploration lesson number one. Here's the second lesson from the Permian Basin of West Texas, in particular the Midland Basin. This is Jim Henry, who presented at one of our Discovery Thinking forums. And here is a central uplift in one of the basins, the Midland Basin, and a very source rock rich deposit called the Wolfcamp. And in the early days, the best wells were vertical wells that had primary porosity and permeability because they were proximal debris flows. And as the play continued to unfold, people stepped out into tighter and tighter rock until they got out into the very source rock rich shale facies. You can see the types of facies here. And then the brilliant insight was that this could not be fracked like the vertical wells could be, but this needed to have horizontal stage fracking. And in time, the wells became longer, there became more fracks, there became more, and this is the evolution of the famous Wolfcamp play, starting out from a conventional play, becoming an unconventional play, and then a big jump. There's a companion basin to the west of here called the Delaware Basin that's deeper and hotter with more pressure and more economics. And then this same play jumped over to the other side of the Center Basin platform. So a series of key discoveries. The third quick example is I'd like to talk about the Bakken Basin in the U.S., the Williston Basin. It's a classic intracratonic basin. You can see the bullseye here. And Orion Skinner, another APG Outstanding Explorer, spoke about how clinoforms were condensing down into the pinched out organic rich sections at the base. And the key was not to drill in the most organic rich section to hydraulically fracture it, but to find benches that were brittle, that had slightly more silt, that could be where the horizontal wells could be placed, that would fracture better, that could then become permeability pathways to access the very rich source rock. And so Orion used techniques of very fine contouring of, in an intracratonic basin, these little benches. And something like this could be very useful for other intracratonic basins or clinoform basins, perhaps even the Vaca Muerta in Argentina. So I'd like to thank Carlos Macellari. Many of you know Carlos. Carlos came and presented. We had a program at APG last March called the APG Global Super Basin Forum, and it was one of the highlights of my presidency, something that I really wanted to bring together the world's experts. And so Carlos talked about South America, and here is some of his work. So I thought we could use this to just focus on a couple of the key trends. So we'll start off with sub-Andean basins and the mountain thrusts, some of the plays and recent developments, and by recent I mean 10 years. And then let's focus on the offshore areas, the things that are happening in Brazil, the things that are happening up in Guyana and Northern Atlantic, and then a few words about intracratonic basins. And so just take a quick tour. And of course, as we focus on the offshore, it's very important to remember that the conjugate margin with Africa has been a very good conceptual map to guide discoveries on both sides, and is fueling a lot of exploration excitement. So let's work the Atlantic margin, and as we look at this illustration also by Carlos, you can see that there have been the very big basins in Campos and Santos, but also up in Guyana, a couple of very exciting things happening, and also down to the south. And so if you look at the creaming curve for Atlantic basins, it looked like things were relatively flat, but then with the advent of enhanced seismic imaging and pre-salt imaging, a rather rapid increase in discoveries. And so here is the Santos Basin, here is the Campos Basin, the Tupi discovery, and the Pau de Acucar Basin or discovery. And I love images, cross sections, and maps are very important. Here's the salt, here's the subsalt Tupi. This is something we've seen before, and I think in the Santos and then in the Campos, very interesting. And there's actually carbonate buildup in here underneath the salt. And these are both, this is written up in an APG memoir that just came out, and I happen to have copies of it here, Memoir 113. If you look at the south, down at Rockhopper, one of the presenters in our Discovery Thinking in 2015, Fiona Macaulay, and later published her work in the Geological Society of London, is looking for seafloor fans that have great significance. So this is an extract out of the types of fans that people are starting to look for. And that, of course, is very big in turbidites along the transform margin in places like Guyana and French Guiana. So we have here the Lisa discovery, a challenging seismic line. There's not a whole lot of really good information in the literature yet, but also here you can see Zadius and you can see Lisa. So two discoveries here is in French Guiana, Zadius, and Lisa in Guyana. And so here is a concept from Clyde Griffith, just showing some of the fan plays along this particular margin. So let's jump over now to the fold and thrust belts. So interesting how in the fold and thrust belts, from time to time, there have been significant jumps where the new trend gets going. And here is a recent one with INGEPET and the Incahazi, which in Bolivia. And that is written up also in the latest Giant Fields memoir that shows the importance of using biostratigraphic markers to get the geometry right. Pretty challenging to image and pretty challenging to drill, but Total and partners really figured out the importance of how this all worked and made a very nice discovery. And then behind the fold and thrust belt, we have these wonderful sub-Andean basins. And so you can see Austral, San Jorge, the Neoquin, Cuyo, Chaco, the Ucali, the Madre de Dios, the Maranon, Oriente, and Llanos, these basins. And so we'll be talking again about Neoquin here shortly, and there'll be a talk that'll be coming up about Neoquin. You can see that for the most part, they're Cretaceous source rocks or Jurassic source rocks. Occasionally there are older source rocks, but for the most part, those are the key source rock intervals. And one of the things that I found that was very interesting in these northern Andean is that there, beneath a lot of the wells, there are deeper pre-Cretaceous sedimentary packages that I'd be very curious of the potential exploration potential for these areas, and some of the people in this room probably know far better than I. So I mentioned this book, the Giant Field book, a couple of times. As an APG president, I'm the marketer in chief. I want to make sure that people know about the useful programs and products and publications that APG does that can help them in their exploration quest. Here's a copy. I'm going to give this to Pedro Alacon as a gift. But I would like for all of you to know that it is in our APG bookstore and is available online. And you can see that we have both Venezuela, Bolivia, and then the Campos and the Santos basins written up in this. And we're working on a new volume. So any of you who have giant fields for in the decade 2010 to 2020 and would like to be included in the next volume, please come see me. So we've talked about the offshore margins. We've talked about the fold and thrust belt, the Andean subbasins. So let's talk about the intracrotonic basins, and let's talk about unconventional resources. And for me, I spend a lot of my time immersed in the unconventional resources in North America. And when you look at a global EIA graph, it's clear that South America has potential for some very large unconventional reserves, and that this is a play, unconventional, that can go global. So I think it's worthwhile to talk a little bit about what are some of the lessons that we can learn that can assist in this energy renaissance. And so EIA, this is from Carlos Masolari, showing that the progressive plays in the onshore, the fold belt, and offshore, and now the potential uptick for the fourth wave of unconventional. And where would these happen? Well, the candidates are, of course, the onshore basins. And so the Vaca Muerta, the Neokin, which has several shale plays, is a prime candidate. But I think it's important that we consider and discuss some of these other basins as a potential. And so one of the things that I love to show about the Permian Basin, a place where I have worked in my early career, is that we had peak production in the 1970s. If you look at the cumulative, the production every year by time, that the best and most production, about 2 million a day, 2 to 3 million a day, or about 750, 800 million a year, was in the 1970s. So this was the heyday. And that after the heyday of conventional drilling, there were a long and relentless decline with a couple of flat spots. But it looked like if you were going to predict where would the Permian Basin be going out to today, most people would take a ruler and predict something out in this area. But an amazing thing happened. And I think we need to understand this. The horizontal and hydraulic fracturing combined in about 2006 created a massive inflection point that creates daily production in the Permian Basin now of 3 million barrels a day, higher than what its peak production. So we are not just going back to the golden glory days, we are actually in a new glory day. And there are predictions that it could be even higher still, because the number of innovations are still happening. There's hydraulic fracturing and varying parameters. There's different fluids that are being applied. Well spacing is getting closer. We're stacking the horizontals. We're using different potential for enhanced recovery hasn't even come into play yet. So there's a lot that can really happen here in the Permian Basin. So this is a prototype of an unconventional play. It has a couple of special things. It has a very good community, and it has the ability for lots of independence to try different techniques. So it's a perfect place to develop new technology. And the other type of Renaissance basin, like the Brazil basins offshore, are the enhanced seismic imaging. Both the hydraulic fracturing of horizontal wells and enhanced seismic imaging are turning old basins into new and exciting places. So let's talk a little bit about the Permian Basin in West Texas, just to see what lessons we can glean. And here's the Midland Basin, and here's the Center Basin Platform. You remember I showed you that this had the Wolfcamp detritus coming into the deep, and then here it's deeper still. So one of the great things about the Permian Basin, West Texas, is it's all mature for oil and gas. No part of the basin is wasted. And right now, the hot areas are in the Midland and the Delaware, but there's actually a lot of people are very interested now in the Center Basin platform for tilted residual oil zones. So that's the next best, greatest thing. But in its essence, here's a cartoon of the Permian Basin. The key elements are that it has excellent source rocks, multiple excellent source rock systems, Ordovician and Devonian and Mississippian, deep in the section, and then it's buried by a whole series of reservoirs, conventional and unconventional, that also have source potential, and that are capped by a regional salt that and evaporate. That is a formula for great success. And the basin has some tectonic elements, but the important thing is that it's largely not a leaky basin, that a lot of the hydrocarbons are kept in place. Those elements right there, my friends, are key for a major superbasin. And one of the things I've often said is it's important to have a map and a cross section, and then you understand the 3D geometry of the basins. But I'm adding to that you really need the fourth dimension, which is time. And so to really characterize some of these basins, we need to have the phases of uplift, subsidence, and uplift to give you the fourth dimension. And in the Permian Basin, very interesting, you can see that after the Permian, there's a downlift, that there is a late uplift. And this I mention because there are structural basins around the world, like in the North Sea of Europe and in Canada, where there are tilts, late structural tilts, and uplift. And if it's an uneven tilt, it can tilt oil water levels, and it can bring in water and hydrodynamic head that can produce and flush structural traps. So here's the Permian Basin. Here is an uplifted version of the Permian Basin. And that tilt creates and meteor drive from that late uplift. There's oil traps that have beneath them a transition zone that has fairly good saturations of oil, not 80% oil saturation like in the actual oil traps, but 30 and 40%, but still mineable. And with CO2 flooding or other types of recovery techniques that are being worked on right now, these have the potential for even more reserves that haven't been calculated. And these could be of interest in places where there's fold and thrust belts. And so I would be curious if this level of potential that could exist along the Andean fold and thrust belt. And one of the values of looking at the super basins, this is a graphic from my good friend Alfredo Guzman from Mexico, is if you look at a place like the Permian, the Midland Basin in West Texas, and compare it to the Tampico-Mazantla Basin, there's a couple of very notable things. The Midland Basin has over 500,000 wells, and the Tampico-Mazantla Basin has less than 3,000. It is very suspicious when you look at the turbidite fill and the cliniform fill of both of these basins, and a lot of similarities with rich source rocks, that the Tampico-Mazantla hasn't produced more oil and doesn't have a higher daily production. So as Alfredo likes to conclude, this may well be an underperforming basin that needs a lot of new technology, but that it could become, we have looking for future Permian basins around the world. And of course, another one of these is the Neokin Basin, and we'll talk about that in a second. I wanted to share some other things that I've learned in my super basin study. There has been a recent stunning discoveries up in the Nunashak play, the Cretaceous of Alaska, which is a super basin in the U.S., and the pays are up in claniforms, and we're going to hear a talk about that shortly. But I wanted to, when I first heard about that, I was so amazed because I wasn't aware that the claniforms actually, the top actually had production elsewhere. And so I did a study. There are some places in the Gulf of Mexico where if you do lithostratigraphic correlations, this is in the Smackover equivalence, which is Oxfordian and Jurassic. But if you do this, you don't really understand the potential. But if you are able to do the chronostratigraphy and you recognize the cliniforms and the value, and you can see here on seismic that there's potential for plays that could be, these could become stratigraphic traps, not just one continuous knot trap. And this is pointed out by some work by John Dolson. Now, this also occurs, I was pleased to find out, that there are plays in the mid-continent of the U.S. where Pennsylvania cliniforms are working. So we're going to hear about that in Alaska. And the best way to get these plays are through horizontal wells. And there is, in Western Siberia, there is another case of production in the cliniforms. So if you just map this as one unit lithostratigraphically and not chronostratigraphically, you're missing the potential for traps and for pay. And of course, there's bright spots. And so lots of lessons can be learned from looking at analogs around the world. And in the Andean Basin of the U.S., the Scoop and the Stack are Mississippian plays that are very prominent. You can see the Woodford Shale is the major source rock there. And people are playing high brittle chert facies at the base of a limestone fabric, and then Maramatian cliniforms that are clastics. So lots of different ways to play horizontal drilling. So now I'd like to talk about the Western Canada Sedimentary Basin, because there may be some lessons for us in the Andean belt. And one of the things that came out of the work of Paul McKay is that when you look at the detachments, the real best places for unconventional plays are out in front of the heavily deformed areas. This is where you can find the Foreland Basin, where it's not all structurally broken up and therefore hard to play. And as you look at the migration in Canada, you can see the key source rocks, the multiple source rock horizons. And you can see that there is a continual lateral movement from high pressure, loaded up in the mountains, to lower pressure. And where oil is able to escape in the oil sands, there are huge tar deposits, which are valuable in and of themselves. However, the area behind the tar that has laterally migrated into the tar is somewhat depleted, whereas places that do not have tar deposits exposed that still have the oil and gas in place. And so those are places that have high pressure because they have not leaked to be tar. And so very important to understand that. And in addition, Paul McKay's work shows that there are different clays that are working, both illite and smectite. And in certain areas, when the clays are still immature and they're smectite, they produce a lot of water with them. Whereas where they're illite, they have already have undergone mineralogic transformation. And so very important mineralogy insights. So the structural cross-section, typical sub-Andean Basin, heavily deformed area, and then the more of a foreland area. So in the Neokin, and I love this diagram that Carlos Masaleri used, using the work of several others before, showing that at the early rift stage, that there were local ocean marine transgression with little localized epicenters with source rock, but that the big series of several source rocks occurred in the sag and the back arc, and that these created a lot of very rich stacked source rocks. And then, of course, finally, the foreland, after the Andean orogeny progressed, we've got a protected area of structure and downwarp basin. And so these are some slides from Carlos, and you can see the basin center. Here's the fold belt for the Neuquén. Here's the Winkle High. Here's the basin center. There's some volcanics. And then when you toggle back and forth, there's multiple source rocks. The Los Molas, which is older, the Vaca Muerta, and then the Agrio. And you can see the richnesses. So this, I'm excited because when you look at some of the great super basins of the world, sometimes they only have one major petroleum system and they're spread out. Here, the potential to stack multiple source rocks, such as shown in this diagram. Here's the north, here's the south, the Winkle High, and you can see the Moles, the Vaca Muerta, and the Agrio, so places where they can be stacked. And then, since we're talking about intra-Protonic basins, one of the basins I'm interested in is the Piranha Basin in Brazil, largely in Brazil. And it has many volcanics, we know, and it also has a series of source rocks, Mesozoic, Jurassic source rocks, Cretaceous source rocks. And what I think is interesting is that the volcanics happen in the Cretaceous around 136 million years ago. So they create local pods of mature source rocks. But then there's a basin, a thermal basin subsidence that also cooks the source rocks. So in this paper by Laruso in the APG Memoir 73, it's written up as being an atypical Permian petroleum system. So the rocks, there's a lot of source rocks in the Permian, and I think this is an interesting basin. And you can see here the Porto Alegre and many volcanics, and here are the volcanics shown in pink. But the source rock and other reservoirs are deeper down. Is there a potential? I don't know. If there's someone in this room that knows more, please let me know. So one of the things I wanted to share with you is that for those who are interested in unconventional projects, APG is putting on another global super basins conference in January of 2019, about October, November, December, about 4 months from now. It'll be in Houston, and we're going to be studying all of the issues of the Permian Basin, the water, the sand, the geotechnical, the transport, the regulatory issues, how the community comes together to innovate. And if you are working the unconventional projects in South America or around the world, this could be of great interest to you. So, as we've talked about analogs, in my own personal experience of 38 years, it started out by studying legendary explorers, and then programs where some of the greats explained their life experiences. And these have all been documented on various websites, and they're one of the most popular things that we do, APG does as a society. And I think because of the great value. And then our Discovery Thinking programs have had tens of thousands of views. We're close to 10,000 attendees at the APG ACE and ICE. We've instituted new programs over the last 5 years that have included plays, focused on playmakers, on individual plays. And then we're just now, as of last year, working on the big basin scale. And there are going to be future conferences and local places. And I'm working on going around the world and focusing on each continent to look at the basins that are working and what lessons can be learned. So I'm teaching exploration courses, in-house courses to industry, and I'm also working with the University of Houston to create a course that can help students at the very beginning of their careers benefit from the tremendous knowledge that has recently been gathered. And for me, the reason why it's important to study all of the basins is that we learn different things from basins that will provide us insights that can be applied in other basins so that they can leapfrog. They don't have, if we can learn something from the Permian Basin in West Texas, there's no sense in recreating it in another basin. We just need to share that information so that people can get an ability to leapfrog with those quantum games. And as I mentioned moments ago about the neokin, some of the richnesses, we're starting to think now, because a lot of the unconventional plays are all about the infrastructure and maximizing the production and minimizing the impact of the infrastructure, very rich basins that are have multiple stacked objectives are particularly promising. So in places like the Appalachians, where there's the Marcellus Shale, or the Williston, where there's the Bakken, basically you've got one really great source rock and it's spread out over a large area. But in the Permian, there are many stacked zones, and in California, many stacked zones, and in the Anadarko, many stacked zones, and possibly in the Neokin and others. And so it's important to really think richness. And as I mentioned, it's very important to understand the timing of basin uplift. And I'd like to think that it's very important to learn from the basin masters so that we can become commercial masters. And to learn from this requires 10,000 hours of study. And so the idea of these programs is to bring experts together so that we can build on the heritage. And here's a graphic from IHS that shows some of the richest basins with stacked pays and very rich. But you can see that the Santos and the Neokin, these are global richnesses. These, of course, are very heavily weighted, but these are pretty high richnesses, and that's, I think, important as we think about the 4D. The other things that I think are in the understanding the class in the foundations of what's important is every single one of the super basins requires at least one world-class petroleum systems, and sometimes many. And we need to understand their reservoirs, if they're planiforms, and how the traps work. And what we've noticed too is that giant fields and the biggest basins are passive margins, rift, and continental basins, hold 2/3 of the biggest production. So compressional basins and wrench basins also have giant fields and also have the potential for very rich reserves, but statistically, they tend to be rarer. And we understand, as I mentioned, the importance of the timing of structural uplift. A lot of basins have yet to be thoroughly examined for stratigraphic traps. One of the great examples is Saudi Arabia. 95% of its production comes from structural traps, and typically mature basins have 20 to 40% of their production, maybe more, from stratigraphic traps. So there's an underperformance here. So I think an assessment of individual basins to see if there are more, if there's systematic unconventional play could be pursued. Very important in these basins, how much of the production has migrated and how much is in sight. And for frackability, there's a lot of importance in understanding the clay mineralogy, smectite-illite. The two difference have an impact on water and on frackability. And then what are the types of infrastructure? What's the community that can produce these basins? And it's interesting when you look at some of the really innovative basins like the Permian Basin of West Texas and the Anadarko, a lot of the early movers tend to be independents. They're the risk takers, and then the big companies come in later. So it's important in building regulations to factor this in. And so when you look at the Permian Basin, you can see there's a lot of companies that are active, and they're fairly, everyone has established acreage positions. So there's gone to a higher level of cooperation and sharing, not just of acreage positions, but also of knowledge. And one of the focuses of the understanding of are the 6 great source rock horizons around the world. There are always more, but if the Silurian, the Devonian, the Penn, Lower Permian, Upper Jurassic, the Cretaceous, and the Oligocene Miocene, 91% of all the oil in the world has come out of these reservoirs. And what's interesting is as more um, unconventional production occurs, we're getting even more out of the richest. So the rich get richer. But there are other ways, looking at plays that are around reservoirs that are around these rich source rocks, called halo plays that are experiencing a lot of rejuvenation. And here is the individuals who've participated in the first Super Basins program. As I mentioned, global experts, but I think the important thing is who are the future global experts. And I'd like to propose that many of them are sitting in this room. And at that conference, it was truly global. And you can see the basins that we focused on, and we are planning in 2020 another conference. So what we found in response to these basins, this is today, October 3rd, we're talking about super basins. We're focused largely on Latin American basins and how they can benefit from the greatest basins in the world. But we've already had a lot of programs up till today that have been very enthusiastic. And these programs are being requested for African basins, for the Permian Basin prototype, and for other conferences going into Europe, and then coming back to Buenos Aires, Latin America in November of 2019. So we have an ongoing effort to really continue these programs. So the bottom line is that these top basins can add a tremendous amount of oil and gas, just the top basins. And the lessons from the top basins benefit all of the basins. And so the nature of the energy renaissance that's making this so exciting is hydraulic fracturing in horizontal wells in unconventional, mainly onshore basins, enhanced seismic imaging in conventional offshore basins. These affect our energy prosperity, helping us to be more environmentally conscious because we have smaller footprints, and they have huge impacts on economy and security and sustainability. And I believe, as I've talked to about 1,000 students as I travel around, that this is an exciting time to be in the energy business, that we are seeing an unprecedented renewed supply of affordable and abundant energy, which is a really good thing for global prosperity. So I encourage all young people that we need your help in this, in geoscience, and to produce this energy. And so I want to thank all of you in the audience and everyone all the geoscientists and colleagues who work to make energy for all of us. Have a great conference.